In exercise 3 from A6, the focus shifts to division by x plus a. So let's go ahead and look at the first problem. Let's look at one of the problems. We're going to go ahead and look at B, and we'll also look at D. In problem B, I've set the problem up just like this. So I'm using polynomial long division here to help me try and get the answer. And so I'm going to first divide x cubed by x to get x squared. Then I multiply. Then I subtract. Remember, I'm subtracting the entire quantity. X cubed minus x cubed is 0. 0 minus ax squared is going to be negative ax squared. I'm going to bring down the 0x. And I'm going to repeat. I'm going to divide. Negative ax squared divided by x is negative ax. I'm then going to multiply. I get negative ax squared minus a squared x. Now I'm going to subtract the entire quantity. Negative minus a minus, this turns plus. Negative plus, the same thing as 0. 0 minus a minus is 0 plus a squared x, so we get left with a squared x. We bring down negative a cubed. We do our division. A squared x divided by x is going to leave us with positive a squared. We do our multiplication. We get a squared x plus a cubed. And now here's where you really have to be careful with your subtraction, because if you don't do your subtraction right, you will get the wrong answer. A squared x minus a squared x is 0. Negative a cubed minus a cubed is negative 2a cubed. And so this is the first time we're seeing a problem where when we do the division, we get a remainder. That is our remainder. Just like if we were to divide 3 into 8, we get 2 remainder 2. And so with this connection to the remainder, 3 is not a factor of 8. Therefore, x plus a is not a factor of x cubed minus a cubed. In D, we're going to use the reverse box method. And I already have it set up, and I'm going to go ahead and complete it. I know that those two values go in my upper left and bottom right hand corners. I do my division, x cubed divided by x to get x squared. Same division problem there. I get a squared. I can fill in this column here, a squared x, and I can fill in this column as ax squared. Now for these to both add up to 0, this has to be a negative a squared x, right? Both of these have to add up to this. The same thing is true with the blue. Both boxes in blue have to add up to 0. And so to get this adding up to 0, we're going to make it a negative ax squared. Now for these two to be true, this must be negative ax. Negative ax times x is negative ax squared. Negative ax times a is negative a squared x. And so when we do our division problem, our answer is equal to x squared minus ax plus a squared. And this is an identity that we just proved. So here are the answers to the 4 problems in exercise number 3. Again, D here, this result is similar to our work in exercise 2, except the middle term is minus ax instead of positive.